There's a moment in every hurricane's life when it stops being weather and becomes something else entirely. A living system, a heat engine, a force that bends coastlines and rewrites maps. And right now, as oceans warm faster than they have in thousands of years, we're watching these storms cross thresholds we didn't think were possible. This is how hurricanes work, and why understanding them might be the most important science lesson you never got. Every hurricane starts the same way. Not with wind, not with rain, but with heat. Somewhere over the open ocean, far beyond where ships travel regularly, far from the attention of tourists checking weather apps, the water temperature climbs past 26 degrees Celsius. That's the magic number, the threshold that separates calm seas from potential catastrophe. Below it, nothing happens. Above it, the atmosphere starts to wake up. Warm water doesn't just sit there. It evaporates constantly, invisibly. And when that moisture rises into cooler air above, it releases energy. Latent heat, the same energy that powers every thunderstorm, every cloud, every raindrop that's ever fallen. But in the tropics, under the right conditions, this energy doesn't dissipate. It organizes. Thunderstorms begin to cluster, not randomly, but with increasing coordination. Winds at different altitudes start to align. The air begins to rotate, slowly at first, driven by the Coriolis effect, the invisible hand of Earth's rotation, then with increasing purpose. Meteorologists call this a tropical disturbance, a loose collection of storms with no center, no structure, no real identity, just a patch of unsettled weather on satellite imagery. Most people never hear about them, most never develop into anything dangerous, but the ocean keeps feeding it, and the atmosphere keeps pulling upward. The temperature differential between the surface and the upper atmosphere creates instability. Air rises faster, more moisture is drawn in, the rotation becomes more defined, and then something shifts. The disturbance tightens, winds begin to spiral inward, drawn toward a center that's forming in real time. Pressure drops, air rushes in to fill the void, and as it does, it picks up speed. This is the moment it becomes a tropical depression. Still weak, still unnamed, but no longer random. From space, you'd see it now. A swirl of clouds tightening like a knot, rain bands wrapping around a core. The first hint of organization. On the ground, you might not notice anything yet. A gray sky, steady rain, wind that's strong but not alarming. But beneath the surface, the system is calculating, testing the environment, sensing whether it can grow. If the ocean is warm enough, if the wind shear is low enough, if the air is unstable enough, it will. And when sustained winds cross 63 kilometers per hour, it graduates and it becomes a tropical storm, and it gets a name. A named storm is different, not just officially, but physically. And the winds are faster now. The rain bands are tighter. The pressure at the center keeps dropping, which means the winds keep accelerating. This is where the hurricane's true power source reveals itself. It's not just about heat, it's about the cycle. Warm ocean water evaporates. That moisture rises and condenses, releasing energy. That energy warms the air, which rises faster, pulling in more moisture from below. It's a feedback loop, self-sustaining, self-amplifying. And as long as the ocean stays warm and the atmosphere stays cooperative, the storm keeps intensifying. At 119 kilometers per hour, it crosses another threshold. It becomes a hurricane. This is where things get strange. As the winds accelerate, they start to pull so tightly around the center that they can't collapse inward anymore. They form a wall, a ring of the most violent weather on Earth. And inside that wall, something impossible happens. The air sinks, the clouds evaporate, the wind stops. This is the eye of the hurricane, and from above, it looks like a perfect circle carved into chaos. From below, if you're unlucky enough to be there, it feels like the storm has ended. The sky clears, sometimes you can see stars, the wind drops to almost nothing. People who don't know better step outside, they think they've survived and the storm has passed. But it hasn't. You're standing in the center of a machine that's still running at full power. The eyewall surrounds you. With winds over 150 kilometers per hour, rain so heavy it moves sideways, and lightning arcing between clouds every few seconds. And then, after 20 or 30 minutes of eerie calm, the backside of the storm arrives. And the wind reverses direction, the rain returns, and people who thought they'd survived realize they were only halfway through. Hurricanes don't just bring one threat, they bring four. First, the wind. At Category 3 strength, winds can strip roofs, topple trees, turn debris into projectiles. At Category 5, they flatten entire neighborhoods. Second, the rain. A single hurricane can dump more than a meter of water in just days. Streets become rivers, rivers become lakes, entire regions drown. Hurricane Harvey in 2017 dropped more than 1.5 meters of rain on parts of Texas. Neighborhoods became temporary lakes. Thousands of people were trapped in their homes. Third, the storm surge. This is the deadliest part. As the hurricane approaches land, it pushes a wall of ocean water ahead of it. That water piles up on the coast, rising 3 meters, 5 meters, sometimes more. Homes are swallowed, cars are swept away. People who stayed behind find themselves trapped in attics, rooftops, anywhere above the rising tide. Storm surge killed more than 1,800 people during Hurricane Katrina in 2005. Not the wind, not the rain, but the water. And fourth, we have the tornadoes. Hurricanes spawn dozens of them hidden in the outer rain bands, invisible, unpredictable, and deadly. Together, these forces don't just damage infrastructure, they erase it. The Saffir-Simpson scale ranks hurricanes from 1 to 5 based on sustained wind speed. Category 1, 119 to 153 kilometers per hour. Dangerous winds. Power outages lasting days. Category 2, 154 to 177 kilometers per hour. Extremely dangerous winds, major roof damage, power outages lasting weeks. Category 3, 178 to 208 kilometers per hour. Devastating damage. This is where the classification changes. 3 and above are considered major hurricanes. Category 4, 209 to 251 kilometers per hour. Catastrophic damage. Areas uninhabitable for months. Category 5, 252 kilometers per hour and above. A high percentage of homes destroyed, areas uninhabitable for months or longer. But the scale only measures wind. It doesn't account for rain or storm surge. Hurricane Harvey was only a Category 4 at landfall, but it killed more than 100 people and caused over $125 billion in damage because it stalled and dumped unprecedented rainfall. The category matters, but it doesn't tell the whole story. Here's what's changing. For most of human history, hurricanes followed predictable patterns. They formed in summer, they weakened over land, they dissipated over cold water. But ocean temperatures are rising, and that's rewriting the rules. Warmer water means more energy means stronger storms. Stronger storms mean more damage, more flooding, more lives disrupted. In the past decade, we've seen hurricanes intensify faster than ever before. Rapid intensification, when a storm strengthens by at least 56 kilometers per hour in 24 hours, used to be rare. Now it's common. Systems that were Category 1 in the morning become Category 4 by nightfall. Hurricane Michael in 2018 went from Category 2 to Category 5 in just over a day. It slammed into the Florida Panhandle with sustained winds of 257 kilometers per hour. We've seen storms that refuse to weaken, that stall over cities for days, dumping rain until entire regions are underwater. We've seen hurricanes form in places they never did before. Farther north, later in the year, over waters that used to be too cold. And scientists warn this is just the beginning. Climate models project that while the total number of hurricanes might not increase significantly, the proportion of major hurricanes will rise substantially. Some models suggest that by the end of this century, Category 5 hurricanes could become twice as common, that storms with winds over 250 kilometers per hour might become regular occurrences. And there's even discussion of adding a Category 6 to the scale. These aren't distant possibilities, they're projections based on current warming trends. Living through a major hurricane changes you. Not just because of the wind or the water, but because of what comes after. The power is gone for weeks, sometimes months. The roads are blocked. The cell towers are down. You can't call for help. You can't check on family. You're cut off from the world, surrounded by wreckage that used to be your neighborhood. The heat becomes unbearable. No air conditioning, no refrigeration, food spoils, water becomes scarce. Recovery doesn't happen in days. It happens in years. Some people never rebuild. Some communities never fully recover. After Hurricane Maria devastated Puerto Rico in 2017, parts of the island were without power for 11 months. Thousands left. Schools closed permanently. Businesses never reopened. And every hurricane season, people who survived one storm watch the forecast with a different kind of fear. Because they know what's possible now. They know how fast things can change, how fragile the infrastructure is, how thin the margin between survival and catastrophe. They know the sound the wind makes when it's strong enough to peel roofs off homes. They know what it feels like to watch water rise, wondering if it will stop before it reaches you. Hurricanes are not anomalies. They're not acts of random violence. They're the atmosphere responding to heat, the ocean redistributing energy, a natural system doing exactly what it's supposed to do. But as we push global temperatures higher, we're not just making hurricanes stronger. We're making them stranger, less predictable, more dangerous. Understanding them won't stop them, but it might help us survive them. It might help us build better, evacuate smarter, respect the power of these storms instead of underestimating it. Because the storms are coming. They always have, they always will. The only question is whether we'll be ready when they do, whether we'll have the infrastructure to withstand them, the warning systems to track them, the will to evacuate when necessary and rebuild when it's over. These storms are nature's engines, massive, powerful, indifferent to human concerns, and in a warming world, they're only getting stronger. If you enjoyed learning about the science behind these incredible storms, be sure to like and subscribe to Cosmic Egg for more deep dives into the forces that shape our world. And check out this video next. Thanks for watching.